Today, you can head your notes with simple machines.
Simple machines?
Yeah.
Okay.
And you know what? I'm going to go ahead and define simple machines for you. Okay? Simple machines give a mechanical advantage to somebody trying to do work, right? It gives a mechanical advantage by doing what? By changing the direction or magnitude or size of, right, the force. Let's put an and here. Direction and or magnitude of a force applied to said work. Okay?
Wait, so let's put it and.
So we're going to do some sort of work. A simple machine could give us a mechanical advantage. How? By changing the direction and or the magnitude of the force that we apply to that work. Actually, that's a pretty good definition. I think that's probably pretty close to the book definition at this point. Anyway.
That's great.
Can somebody give me an example? There are 6. Can you think of, I've had some really interesting answers. Give me one of the 6 simple machines. Go. A pencil. Depending on how you use it, it could be one that I'm thinking of.
A stick.
A screw. Okay, all right, we'll come back to the pencil. So a screw. All right, now here comes the artwork that you all paid admission for today to see.
So write it, copy it?
You're going to draw it. Yeah, you're going to copy just right. Now, when you copy it, it's okay if you can't draw as beautifully as I can. Okay, it's all right. So, and I'm going to use a Phillips head, which even they're the bane of my existence. I can't stand Phillips head screws. They get stripped out. Anyway, so draw an oval with a plus sign. That's your Phillips head of the screw. And then draw like a really skinny triangle. And then, this is the really hard part for most people that aren't artistic like I am. Draw little swirlies all the way up. And it kind of looks like a screw.
Good job.
All right, now check it out. You okay? All right. So a screw works. Hello? A lot of extra talking. I know you guys probably finished the drawing before I started it, but you take a rotational force. In this case, I have it turning it clockwise, and it changes the direction, just like the definition of a simple machine says. So rotational force is now being turned into a forward driving force.
That's great.
Okay. Now, if I turned it counterclockwise, it would come up, assuming it's a normal righty-tighty, lefty-loosey threads. You do run into reverse threads sometimes, but they're pretty rare. In the common world, usually it's righty-tighty, lefty-loosey. Any questions on a screw?
Lefty, loosey, righty.
Righty-tighty.
Oh, sorry, no.
Yeah.
Lefty and right.
If you go
Righty, righty,
left counterclockwise, it'll probably back out.
No, I know. I'm saying like if it was different.
Have you heard that before? It's pretty well known.
No, lefty, tighty, righty, loosey.
No, lefty-loosey, righty-tighty.
You said sometimes it'll come across the.
Yes, if they're reverse thread. Yep. If it's threaded backwards. All right. So I'll demonstrate something. Okay. I've got my yardstick or my meter stick, and let's say this book is too heavy for me to lift, so I need some mechanical advantage. What? A lever. It is a meter stick, but you could use it as a lever, right? All right, here we go. This point right here, the pivot point, is called a what? Does anybody know? What? Huh? A fulcrum.
What are you drawing?
That sounds like a superhero.
That's a lever.
All right. If I apply a force down on this side of the lever, you guys looking? And remind me to move around so everybody can see. If I apply a force down on this side, what's going to happen to that side?
It's gonna go up.
It's going to go up. It's like a seesaw, right? If we were dealing with a wheelbarrow, let's say this is the pivot point on the wheelbarrow where the wheel is, okay? The longer the handles are on the wheelbarrow, the easier it is to lift whatever load is in the barrel. Wheelbarrow. Anyway, sometimes you think too hard about words. If you extended the handles out further, it would give you more mechanical advantage, but then you'd be like picking the way up like this, right? So you sacrifice, when you're gaining a mechanical advantage, oftentimes you're trading traveling more distance to make the work easier. Does that make sense? So in a minute we're going to talk about another one. Let's just keep going. Wheel. Good. Oop, I'm switching colors. No, I'm not.
Oh. I think we should.
Wheel axle combo. Wheel axle combo. So you have, usually the force is input, doesn't have to be, but sometimes the input is, the force is applied on the axle. And again, it's a rotational force. And then that axle is attached to your wheel. And then that is going to be rotating in the same direction.
Oh, I see.
Those are definitely Michelin's.
Well, I'm drawing that.
This is an axle and a wheel.
Oh, I see it now.
You're looking at it on the side, like yeah. Okay. Thank you. I think it's a pretty good wheel and axle myself.
It looks like a T.
Okay.
It is a T.
Okay. Now, so now think about this though. If I wanted to, let's say a car's broken down, and I want to apply a force directly onto the wheel, or to get it to move, or I could grab the axle and try to turn it. Which one's going to be easier? Pushing on and getting the wheel rolling, or taking the axle and trying to turn it like that? The wheel, right? And the reason is you're trading. If you're rolling on the wheel, you're going to be traveling a longer distance while you're applying the force, right? Because the circumference of the wheel is bigger than the axle. But you can actually manage to do it. Good luck trying to grab that axle and turn it over. The only way you'd probably be able to do it is if you had like a wrench or something that you could get on that axle, and then you're back off further again, which would be the same thing as with the wheel, right? So anyway, sometimes you'll have it reversed, where the axle's not powering the wheel, but the wheel is powering the axle, right? You could do that too. So if somebody was applying a force to the wheel. Your bicycle, anybody have a bicycle? Or have ever had a bicycle with gears?
Yeah.
So the gear, basically you're changing the size of your final, I'm not a bike expert, good grief, I'm going to start blushing here because I don't know anything about bikes. But the taller the gear, the harder it is, right? But you're going to travel further per pedal, right? Anyway, all right, we're missing a couple. So we've got 3 so far. There's 3 more. A rock. What do you got? It's called a pulley. So you pull on. So let's draw it. With a pulley, you've got. I'm gonna try to get like fancy here. I'm gonna draw more like an oval we're going to say we're like at the side here. And then you have a chain or a cable or a rope. That's not bad. And of course, it's spinning on its own axis there too, right? And then if you pull down on one side, what happens to the other? Yeah, it's going to redirect the direction of the force. And if you had more than one pulley arranged properly, you could reduce the force required to lift the load too. But again, it would be a trade-off. Let me get out of the way. So if you've got multiple pulleys working together, you can reduce the working effort to lift something, but you're going to have to pull more distance than it's being lifted. A good example is, you ever see the garage doors that have the chain on the side, and it's one of the roll-up garage doors, and you're pulling out, it seems like forever, right? Because like if you pull 3 feet down, the door's only moving like 1 foot. Does that make sense? Something like that. All right, we got 2 more.
Tank tracks.
A what?
Tank tracks.
No, what? Ramp, otherwise known as a incline plane. So, incline plane. And it looks like a triangle with a right angle, right? And so here we're applying a force this way, and the ramp is just changing the direction slightly up. And you could think about an inclined plane like this. Let's say there's a platform at the top, and there's a box here, or there's a box here, right? Is it easier to lift that weight straight up and put it on the platform? Or maybe you have to go a little further, but you can use the ramp to reduce the effort. It'll be a increased distance with reduced effort, or increased effort with less distance.
What?
It's a trade-off. Here's another example. If I wanted to climb onto my roof, I could climb a ladder, yes? Or could, you know those mobile staircases, you could like roll up to it and then you could climb the stairs? Which one would be easier to climb? The stairs. Because it's at less of an angle, less aggressive. Yeah, makes it easier. But now you got to go further, right? Than if taking the ladder. One more. We're just missing one. You've been doing good, for sure. Think about if you put 2 inclined planes. Here, I'll just draw another one. Now what do you have?
Aerodynamic.
A wedge. Okay? So if you take 2 inclined planes and slap their backs against each other, you end up with a wedge. And with a wedge, that force applied this way gets split. So, for example, if I want to chop some firewood, whether I'm using a mechanical or hydraulic log press, log splitter, or if I'm using a splitting axe, either way I'm using a wedge, right? I'm applying a force and it's going to split half of the wood off this way and half of it off this way, or whatever, depending on where I put it on the log. Any questions on the 6? 1, 2, 3, 4, 5, 6. Yeah. 6 simple machines. And again, if your art doesn't look quite as good as mine, I understand. It's pretty good, isn't it? No, I walked around in an earlier class, and this girl had like the most beautiful pictures of. I'm like, you got that from mine?